I am still on section 1A, which is just an introduction. I am just going from a petrol vehicle towards electric vehicle, step by step telling you what are the things happening. And the fourth part of this is vehicle auxiliary. There are, besides the drivetrain, which drives the motors, drives the wheels and therefore drives the vehicle with increased decreased speed, increased decreased torque, there are vehicle auxiliary, and you need to power these auxiliary. What are these auxiliary? I did mention that, but example, power brakes, power steering and air conditioning. These three are more or less today a must in a car, not required in a two-wheeler, not required in a three-wheeler. In fact, even the car did not have it 25 years back. So, what used to happen? We had to really push our legs like anything, mechanical brake, to suddenly brake. Today, that used to result into accidents. So, people did, what was designed was a power brake. So, you apply even small amount of force. Now, remember that if you require large force, only well built bodied people could drive it. The young children, many women would find it difficult. By introducing power brakes, you have made it younger people, less well built people, older people who do not have that much energy, women who do not have that much force. Power brakes have made it easy. You need a very small power to even completely stop the vehicle. The power brakes. What you are applying gets amplified. Similarly, power steering. I remember as a kid trying to just steer a vehicle, and my hands will pain, because completely turning the vehicle and rapidly took a lot of power. You are more or less using your power, hand power, to move the tire. And then we got what is called power steering. You virtually can do it with one finger. Today, almost all vehicles have power steering. Then, for first 25 years of my life, I had never stepped into a car which had the air conditioner. Today, every car has air conditioning. Now, the reason I am mentioning all these three things require power. Where does that power come from? In a petrol engine, as I pointed out earlier, the petrol will drive the engine will then drive the hydraulics, compression air, and that hydraulic will then drive through hydraulic pump, through belt and shaft, will drive power brakes, power steering and air conditioning. And there is a lot of losses. 70 to 80% is the best efficiency that you could get with hydraulics. But well, fine, at least you could convert this and run power brakes, power steering, air conditioning. Not so with electric vehicle. Electric vehicle drives, you use motor for brakes, motors for power steering and motors for air conditioners. Essentially, electric motors, electricity driven motors will do this. You may need DC-DC converters to get the required voltage. But power brakes, power steering and air conditioning are not the only thing. Battery is now used therefore for all auxiliary electric power. It is used as for a petrol vehicle, use dynamometer used in petrol vehicles to charge auxiliary battery, and then battery electrically driven power brakes, power steering and air conditioner. If it is electric vehicle and you have big battery anyway, no auxiliary battery, use DC-DC converter. So, from drive voltage of 350 volt, you get to 12 volt, 24 volt, 5 volt, and then you use auxiliary power, low power and low voltage. There are many other things which require electricity: headlights, tail lights, flashlights, vehicle interior lights, all signal lights, motors for wipers, windows, automatic opening and closing of doors, all these things require motors and sensors and actuators, motor sensors and actuators, all are electrical. There is so much electrical in a vehicle, there is so much of electrical wiring. There is typically a vehicle control unit. Entertainment and guidance has become part of a vehicle. Other electronics, communications, sensors, rear view more projection, and you are adding more and more electrical stuff, electronic stuff in a vehicle. The amount of electrical wiring that you need to do is huge, runs into kilometers, total number of conductors in a vehicle. You won't believe that. In a car, you take all the wires and stretch it, it will be more than a kilometer. Can you believe? In a 3-meter car or 2-meter car, 2 and 3-meter car, you have kilometers, because so much of wiring is required. So much of electricity is flowing from every device to the battery, from every sensor to the battery, every indicator, there is wiring. It is called wiring harness, and it has to be done very carefully, because cut in this wiring harness can result into a big problem. Now, all this has happened before electric vehicles have come. It has happened over the last 10-15 years. Now, we will leverage that. Yesterday, we used dynamometer to convert the petrol moving engine to hydraulics, and then petrol engine drive itself using dynamometer could produce electricity which could charge an auxiliary battery. For electric vehicle, I just use the main battery and use DC-DC converter. This is the vehicle auxiliary. This is the second assignment that I am ready to give now. I think we have done enough on calculating speed, torque, power, and small problems we should be able to do. This will give you a very good understanding. Small computation, almost all of them, very short answers, very quick. If you go through the lectures carefully, you will be able to do this in no time. The first part, where I am still building from a petrol vehicle to electric vehicle, 1A, point 1, 2, 3, 4 I have done. I now come to 5, where I am now coming to the last part, outside the vehicle. Petrol pumps, which will fill the petrol, equivalent charging stations, which will charge my battery. Very quick introduction of that, and the first chapter gone. None. Infrastructure, city infrastructure, town infrastructure, rural infrastructure required for vehicles to run. Vehicle fuel tank, petrol, you need petrol filling, regular. You can run so many kilometers, after that you need to fill the petrol, which means there has to be a petrol pump nearby. What if you do not have? You can't run a vehicle. You go to some remote areas, there is no petrol pump, you are in trouble. You do not even know how to come back. So, you need petrol pumps at all over, and that infrastructure has been built over 100 years, 75 years. Similarly, because whatever petrol you fill will get run out. Similarly, whatever charge you put in a battery will run out, and you will need a place to charge the battery. Petrol pumps, as I said, has been set up widely. A vehicle fuel fills it in a few minutes and can drive for few hundred kilometers, 200 kilometers, 250 in a few minutes. There are refineries, of course, petrol is not easily available. There are refineries all over, which takes the whole thing to petrol pumps. It is doing it almost every day. But there is a business, the petrol price includes all of this, and it has been built over 75 years. There is a lot of infrastructure, huge expenses. Without those refineries, if you did not extract oil, if you did not refine the oil, you could not take it to the petrol pump and you couldn't take it to the vehicle. Hundreds of thousands of crores of rupees has been spent over last 75 years in building this infrastructure, which enables a petrol vehicle to run. And when we want to replace this with electric vehicle, we require equivalent infrastructure which is not there. So overnight it cannot be done. But remember, this has been built over 75 years. It is in no manner better than electrical infrastructure, but it is there. We are used to it. Change is always difficult. Electric vehicles, they require charging stations to charge vehicles. Fortunately, electric grid is already there widely. If electric grid was not there, if power was not produced, electricity was not produced and was available everywhere, we would have been in big trouble. Fortunately, electricity grid is today nationwide, almost worldwide. Most even remote parts are getting electricity. Every home is getting electricity. That is a plus. Every home is not getting petrol. The problem is, it takes a long time to charge electric vehicles. It can't be done in a few minutes. How long does it take? Ideally 5 hours, 6 hours. So what is the best place to charge a vehicle? Home. Home vehicle is parked in the night. You have electricity. You just have to have the right infrastructure, charge the vehicle, no problem. Where else can you easily charge the vehicle? Office. You come park your vehicle, work whole day. Easily, electricity is there, you can charge. Where else? A cinema hall. You go there at least for 2.5 or 3 hours. You can charge the vehicle, at least half, maybe 3/4. A shopping center, if you are going to spend 1 or 2 hours, you can easily charge the vehicle. This is not normal. But if you want to go somewhere in 2 minutes, you charge the vehicle, sorry. So you think differently in terms of charging. Unfortunately, we are still not thinking differently. Most charging will be done at home, offices, parking lots. You are going to park the vehicle for a few hours. Cinema halls, shopping centers. These are the place where you have to have even slow charging. 3-4 hours is enough, good enough. Some fast charging. But if you think you can charge like a petrol pump 2 hours, it will not happen. How long does a battery takes to charge? This is the important question, and this is what we will learn in this course. Ideally, slow charge is best. 5 hours is good, 6 hours is good, 7 hours is even better. That's what increases the life, and if possible at moderate temperature. So if you are at home in the night, your charging is great, temperature is lower. If you are even in a shopping parking lot, covered parking lot, temperature is lower, you can charge it, and charge it slow, less of a problem. You can do fast charging. For example, 1 hour charging is possible. But it will impact the life of the battery. And remember, battery is expensive. Any attempt to fast charge will hurt the battery. You have to take a call. Once in a while, therefore, you can do fast charge. If you want to do regularly, you will get into problem. It will require batteries with certain chemistry which allow fast charge. Not all batteries do that. Super fast charger, 15 minutes charger, you require special battery, extremely expensive. You are getting there, but still not like petrol filling in a few minutes. But remember, what has to go into the minds of those bureaucrats who are sitting there and slowing down the electric vehicle. They keep talking about charging station, not recognizing the best place to charge a vehicle. First is home, second is office, third is a parking lot, cinema halls, shopping centers, and do slow charge. a little bit of fast charge here and there. If you look at the places where the maximum number of vehicles has gone to electric vehicles, you will see 80-90% charge vehicles are charged, 90% charging is done at home, offices, parking lots, cinema halls, shopping centers. You are talking about 5 to 10% you do fast charging. That is not the bottling, that is when you need it, yes, it is desirable to have it, and we will talk about different options there. There is also another very important unit, vehicle control unit, sometimes called MCU, communicates with battery and controller, typically over a bus called CAN bus, may have external wireless interfaces, may have also other interfaces like sensors, GPS, load sensors, installation, etc. Then this vehicle control unit can manage motor and controller, collects data during drive, and possible to download all these parameters, including of motors and batteries, to a central location, and you can do all things like geofencing, limiting temperature of operation, limiting speeds and all those things. These are desirable things which electric vehicle more or less gives you free, and you can easily add, does not cost you very much. The other important thing that you need to worry about is battery power and range required. What is the battery power? I talked about capacity. Electric power is continuously used by motor. So, the energy used is integration of power either over distance or power over time, over drive range. So, energy is P dt or P dt or P ds. Over a certain distance, over a drive range, you can integrate, you will get energy, or power over time, and you will get the energy. Now, this energy is important, but this is the energy that a battery has to have. Gradients may result into higher power and energy usage, but remember, when you can go down, you can regenerate. So, if you have good regeneration, it does not hurt you much. Inefficiencies in motors and controllers can add power energy consumed. Losses due to inefficiencies can be 10 to 20%. And at lower speed, energy efficiency can still be lower. So, you don't worry about all these things. Finally, auxiliary power usage can also take part of your energy. So, from the total energy, you have to subtract the auxiliary power, take out the inefficiencies, then figure out how much energy is available and whether your drive is good enough. Power used is power of motor inefficiency, power of controller inefficiency, power of auxiliary. Battery to be designed to provide energy over a range as well as peak power. Peak power will be discharge rate, and energy over a range is the capacity of the battery. This is what you need to do. And battery designed for certain energy in kilowatt hour. It is measured in terms of voltage multiplied by ampere hour divided by 1000. Voltage multiplied by ampere hour will give you watt hour, divided by 1000 will give you kilowatt hour. So, it comes from cell capacity, the ampere hour will come from cell capacity, defined in terms of voltage and current into hours, that is called ampere hour. So, you have to, for cells you have to take voltage and ampere hour, then you have to, that will give you watt hour for a cell, and then number of cells in series and parallels you have to take into account, multiply with that, it will give you total watt hour. For long life of rechargeable battery, it is never fully emptied or reused. I mentioned that to you. Leaving certain amount of energy at the top, basically you never fully charge. Leaving certain energy at the bottom, you never fully discharge, and that is called depth of discharge. Usable energy is therefore a certain percentage of total energy, typically 85%. of total capacity, referred to as depth of discharge. This is important. We will repeat all these things as we go on. Also, battery capacity reduces as you use them. Remember, it has a certain life. You start with a life of, let us say, 100. After some time, capacity is reduced to 95, then to 90, 70, 85, 80. Now, it will limit your range. You may want to then change the battery. Every charge-discharge cycle reduces the capacity. When battery remaining capacity is, let us say, 80%, then we will say range is proportionally reduced, and it is time for use of that battery in electric vehicle is over and you need replacement. It does not mean that battery has no life left. It may have life left for stationary use, not for the vehicle use. So, if X percentage of energy only you are going to use in one cycle, and after it reduces by Y percentage from the beginning 100%, you will retire the battery, then the available energy at the end of its cycle life is only X into Y into C, could be as low as 0.68 C, remember that. So, if you start with 10 kilowatt hour of battery, but you are using only 85%, so only effectively 8.5 kilowatt hour battery. End of life 0.85 into 80%, probably 0.68, 6.8 kilowatt hour. Remember that to that extent you can only drive that much. Remember that, and this is something that you cannot forget. The battery power is important. Even when batteries have sufficient energy, rate at which power can be drawn out, that is the C rate, is limited. If you try to draw too much power, it hurts the battery life. Rate of charge or discharge impacts the usable life cycle of battery. And as I point out, similarly, if you try to charge it fast, it impacts the life cycle of the battery. Higher rate of charging, discharging also heats up the battery. Heating of the battery also impacts the life of the battery. So, the battery is designed to be charged or discharged at certain peak power capability, never exceeds that. Charge discharge rate depend on the size of the battery as well as number of nature of cells. This will be discussed in detail when we discuss the battery chapter. We are ready for the assignment 1.3. These are all small assignment. A battery is 48 volt, 30 ampere hour, is designed to power electric two-wheeler. Battery is designed to operate at 80% depth of discharge. End of life can be considered when it reaches 70% initial capacity. Compute the total energy in battery in kilowatt hour. What is the maximum amount of usable energy for each cycle at the beginning of the life and at the end of life, when there is only 70% of initial capacity. Now, this is important. And with this, I have finished section 1A, which is the basic introduction of electric vehicle. And now, I will come to electric vehicles in India, in Indian context, talk about numbers, talk about all kinds of things which will impact electric vehicle. Including in the end, I am also going to talk about what causes fire. Introduce here, discuss in detail later. This is still introduction. So, part B of the introduction, which will be specifically talking about electric vehicle in Indian context, we will take up next. Thank you for the day.